right, 2.7, day 2. For this part of the lesson, we're going to use the horizontal line test to determine if a function has an inverse function. We're going to use the graph of a one-to-one function to graph its inverse function. And we're going to find the inverse of a function and graph both functions on the same axes. All right, so first we talk about the horizontal line test. It says a function f has an inverse that is a function if there is no horizontal line that intersects the graph of the function f at more than one point. So what it's saying is that, you remember the vertical line test we talked about? You had some graph and you took a vertical line, and whether it was your pencil or your pen or your finger, anyways, you took some vertical line and you went across your graph, and as long as it didn't touch it more than once, that meant it was a function. Okay, so the horizontal line test says we're going to go across that graph horizontally though, and if it touches, whoops, that's not very straight. And if it touches the graph in more than one point, then the inverse won't be a function, okay, which means it doesn't have an inverse that's a function. All graphs have an inverse, but what we're worried about is it going to be a function? All right. So let's look at example 1 here. It says, which of the following graphs represent functions that have inverse functions? And so they gave me on A, they gave me the graph of the absolute value of x, and they drew that blue horizontal line across it. So does this pass the horizontal line test? Well, let's see. It touches it here, and it touches it there. So it touches it more than once. Try this, a little bigger circle. So it touches it more than once. So therefore, it fails the horizontal line test, which means that the inverse is not a function. Or we could say, because it asks which of the following graphs represent functions, then we could, it does not have an inverse function, okay? Whichever way you want to word it. Now, look at B. B, they gave us an exponential function here, and we want to know, does it pass the horizontal line test so that we can find out if its inverse is going to be a function. And so it doesn't matter which horizontal line we actually look at, okay? We'll notice that each time it only touches it once. So therefore, that means that the inverse is a function. Okay, then the graphs of the inverse of f is a reflection of the graph of f about the line y equals x. So the line y equals x, remember it's going to be the line where all of my y's are equal to all my x's. So if we use our x's, -2 to +2, then that means if y is equal to x, when x is -2, y is -2. When x is -1, y is -1. When x is 0, y is 0, and so forth. Then when we go to plot these, we got 1, 1, 2, 2, 3, 3, 0, 0. We could go the other way as well. And then we connect them. We end up with a line that looks something like this. And so what it's saying is that if the graph are inverses of each other, they're going to be reflections across that line. All right, so in example 2 here, it tells us to use the graph of f to draw the graph of the inverse of f. So the first thing I'm going to do is I'm going to make myself a table here for f of x. And so we can see some ordered pairs here. And so we have the first order pair, which is like -3, -2. Then we have another one here at -2, 2. And we have one right here, which is at like 4, 1. Now for our inverse, remember we talked in the last lesson that the big thing about inverses is that we're going to switch our x and y's. So what that means here is that all of these x's are going to become the y's of the inverse. So my y's are now -3, -2, and 4. All of these y's are going to become the x's of my inverse. So my x's are now -2, +2, and 1. And now we're going to go graph those. So we got -2, -3, 2, -2, and we got 1, 4. Now, we're going to draw in that line y equals x. and we're going to check to make sure that it's a reflection about that line. So if you look at this piece here, does it look like it's a reflection of that piece? It does. What about this point? Is it a reflection of that point across that line? It is. And even right here, now remember I drew this, so it's not going to be perfect, but they're awful close, so they look like they're reflections as well. So therefore, we've got our new graph. We've got our graph of the inverse up here.